Okay, guys, welcome to today's class. Today we are going to discuss about linked list. Earlier we have discussed on the topic array and we have solved a lot of problems on the array list, right? So we will revisit the arrays problems once again later on, but agenda of today's class is to learn a new data structure called linked list. Linked list. What are we going to cover today? So in the linked list, first of all, we are going to understand the fundamentals of linked list. What is linked list? Why do we need linked list? Right? And other aspect of linked list, meaning basic concepts of linked list. Okay? Overview of linked list. Okay? Once we understand the overview of linked list, what is linked list, why do we need this one, right? And then later on we will solve couple of problems on the linked list, right? So also we will also learn about what are the different basic operations we can perform on the linked list. Okay, so these are the important concepts. So what the way I am going to make you understand here is I will lay the foundation from the basic, and from there we can go to till the advanced layer, meaning we will first understand the basic of linked list, what are the different basic operations we can perform on the linked list, right? And later on, how will you use those concepts to solve the problem on the linked list? So far with me? So we need to solve lots of lot of problems on linked list. Okay, I am always repeating, and today I am also going to repeat. If you wanted, if you want to master on the data structure and algorithm, the only way to master is practice, practice, and practice. Okay, solve the problem, understand the problem, solve the problem, do the basic intuition, right? Do the dry run, right? Make your hand dirty, then only way you will be able to master this all these data structure algorithm concepts and problems. Okay, so with that, let me start with the linked list. Okay, so what is linked list? What is linked list? So a linked list is a data structure. Give me a second, let me readjust this one. Okay, I readjusted this one. Okay, so now we are going to understand linked list. So what is linked list? So a linked list is a data structure. What is linked list? It is a data structure that contains sequence of nodes where each node contains a value and reference to the next node in the sequence. Okay, so what is linked list? It is also a data structure, the way we discuss the arrays. So we have another data structure that is linked list. So a linked list is a data structure that contains sequence of nodes where each node contains a value and reference to the next node in the sequence. Meaning, let's say one particular node will have the data and address of the next node, so that the next node can be linked with the first node. Okay, now move on. So we have discussed about the array. So linked list and arrays. Understand this concept. Linked list and arrays both are used to store a collection of same type of data. We discussed what do we mean by same type of data. Same type of data means if you are storing integer value, you should only store integer value. If you are storing float values, you should only store float values. Okay, if you are storing any complex type like object type, you should store same type of object. Okay, so this is the similarity between linked list and arrays. So linked list and arrays both are used to store a collection of the same type of data, meaning a data type can be a simple primitive integer or a complex object of a particular class. Just now I mentioned, right? It could be integer, it could be float, or it could be an employee class object. However, the structure of linked list, the structure of linked list is different as compared to arrays. So similarities is both store same type of data, but the way it stores and the way it is structured, it is entirely different between the linked list and arrays. So that is the reason I mention here the structure of linked list is different as compared to the arrays. Another characteristics is linked list and arrays both are used to store a collection of the same type of data. You know, right? These linked list and arrays both store a collection of data, meaning if you wanted to store more than one data, then we need a collection, and to store the collection we have a different data structure that is called linked list or arrays. So far with me, guys? Any doubt here? No. Okay, let's move on. Okay, now the next question is, if you are understanding any data structure, you need to also know where exactly this data structure are used or it is already implemented. Okay, so what are the different applications or concept or topic where this linked list has been used? Hash map. In Java, there is a collection that is called hash map, right? So in when the way hash map is implemented, it internally uses linked list. Then the file system. So if you think about the file system, you have a folder file, right? Under that folder you could have different folder, right? So it is, you can consider, think that one is linked to other is linked to other, right? And there is a adjacency list. We will talk about this adjacency list later on. Okay, so these are the applications, or you can say topic, where linked list is already implemented. Okay, now I just mentioned that the way arrays store the data and the way linked list stores the data, there is a difference between the structure. Okay, to understand that, let's talk about the linked list structure. The linked list structure. So how will you understand what the structure of the linked list? You can think of, it is formed by nodes. It is formed by nodes that are linked together like a chain, like a chain. one node is connected to other node is connected to other node, and the second node is connected to third node is connected to fourth node, and so on. Okay, it is making a chain, right? In a playground, maybe you have played some game. So one people people is connected with all the hands, right? And they can make a circle, they can make a line, right? Think like that, it is a kind of chain. Okay, and each node holds data along with a pointer to the next node in the list. So if you look at this example here, so this is one node, okay, and this one node contains this data and the pointer. And what is pointer here? This pointer is nothing but it holds the address of the next node, this node. Okay, so if we wanted to get this node, how will you get this node? From this first node. Why? Because this first node has the address of this second node. Similarly, this is the third node. In this third node address is stored in the second node, and this pointer represents this address. This pointer represents the address of what? Address of the next node. Okay, this. So if you look at this arrow, so this arrow, it joins all the nodes. Basically, it is connecting all the nodes. So here, this is nothing but a linked list. So what we discussed, linked list is a data structure that contains a node and all the nodes are connected like a chain. Okay, if you look at this one, this is the linked list. Okay, and when we talking about data, you see here, this is one data, this is another data, and this is the third data, right? So this data must be same type, meaning if it is an integer, meaning let's say if it is a 10, then it should also be 20, 30. Value can be different, but it should be always a integer type if you define that. Okay, and in the list, the first node is called the head node. What we call the first node? The first node is called the head node, and the last node is called the tail. So we have a head node that represents or indicates the first node, and we have a tail that represents the last node of the list. So far with me, guys?
Yes.
And you mention here, I see last node until it contains a cycle. So we'll discuss about, this is the important concept we will discuss about later on. What do you mean by cycle? Just make a note in your mind. Okay, but this is the structure. So if you compare the structure of the linked list and what you have learned in the array, it is entirely different. In arrays we don't have a concept of pointer. Are you guys with me? Are you guys with me?
Yes.
Okay, so
Yes.
this is the head node and this is the tail node. Okay, now let's move on. Okay, now how will you visualize the linked list? How will you visualize the linked list? So you can visualize a linked list as a sequence of nodes. I am repeating again so that you can understand and it will be injected in your head. You can visualize linked list as a sequence of nodes connected by arrows that point to the next node into the sequence. For an example, what we just learned here, first node is nothing but your head node, correct? So if you come here, so what I am saying, so initially initially link, let's say initially linked list is empty, means there is no node at all. So whenever you create a first node, okay, that node represents your head node. So far with me, guys, so far with me.
Yes.
Yes. Okay. So when you create this one, so let me take this pencil. So this is representing, okay, let me take the another one. So basically this represents the first node. Okay. If you see here, what is the value here? What is the value here? Value is 1, and that represents the first node. Okay. Now in linked list, all nodes are connected, right? All nodes are connected. So head dot next. If you look at this one, head dot next, what are we creating? We are creating a new node here. What is called new node? List node 2. So whenever we are creating this new node, right, this new node will be assigned to the address of this next node. So if you mention this first node, let me take this pencil. If you mention this first node, it is represented like this one, right? It has two parts. One is the data part, one, right? And another is the pointer that points to the next node. So here you have created a next node, but how will you how will you connect this node, right? So what is your head is a first node, right? Head is a first node. Now first node should be connected with the second node, meaning here this pointer, what will be this pointer? This pointer is the address of the second node, meaning this address will be assigned here. Address will be assigned here. So far with me, guys. Now,
Yes.
now visualize this one. Now head dot next, then dot next you need to do. Okay, and there is another node, right? Means this is your head. Think like this one. Okay, think like this one. This is your head node, right? Head dot next, head dot next. What it represent? It represents the next node. Now head dot next represents this node, right? Similarly, head dot next represents this node. So far with me, guys. Any doubt? Think like this one. So let's say this is your head node, correct? Head node. And let's say the data is 10 here. Okay. Now this is let's say this is another node. Think like this one. This is another node and the value is 20. Okay. Let's say this is another node. The value is 30. Okay. Now, these all are the different nodes. Node 1, let's say called it node 2, let's call it node 3. Okay. So how will you connect this one? These all nodes are, let's say, in the space. How will you connect this one? The address of this one will be assigned here. Meaning what? This is the next, right? This is a pointer that points to the next node. Now here, this is the another third node. Now this is the next that points here. So if you think like this one, initially this is the head, right? Now next, head dot next. What it will represent? It represents this one, right? Now when you do head dot, okay, where is head node, guys? This is your head node. Okay, head dot next. what it represents, which node? This node. Correct. Head dot next is this node. Now if I put head dot next, where it will present?
Node 3.
3 1. When I put head dot, see, think like this one. Where are you now? Hey, when I say just only head, where are you? Only if I say head, where are you? This
Node.
head is this one, right? Now head dot next. When I say head dot next, what do you understand by this one? This node. When I say head dot next, what did you understand by this one? This node. Correct. Now head dot next. What will happen? There will be another node here. 40. Okay, this way you can visualize the linked list. It will be more clear in the next section. Okay, any doubt here?
No.
Ritik, Kshitiz, Kisan is not there. Okay, okay, let's move on. Okay. Um, So far, we have just discussed the overview of linked list. What is linked list? What are the applications where linked list is used? What is the structure of linked list? Now we are going to implement the linked list by ourselves. Okay. So if you need to implement a linked list, how will you implement that one? Meaning, what are the classes you need to know and how you can write those classes. Okay, so uh, so linked list implementation. So in Java, if you wanted to implement the linked list in Java, so two classes needed for the implementation. What are the two classes? One class is node, right? And the another class is linked list. Right. So here your node class will contain data and the address or pointer of the next node. And your linked list class is a class that connect all the nodes, meaning you can perform operations on the linked list. So far with me? So if you look at this class node, when you write a class node, so how will you write? Public class node T and T data and node next node. So understand this one. What is T here? In T represents Java generics, meanings it whatever the data generics means if you create a integer type, it will take integer type. If you create a string type, it will create a string type. We will discuss about these generics later on, though it is not uh, as part of this linked list class, but I will, for your reference, for your understanding, I am going to just lay the foundation of generics also, give you the some basic understanding of generics so that later on you can go and just read about Java generics separately. But as for this class, this is a separate topic. Okay. Now, when you define a class node, here T, think like this one, T is a generic. Whenever you, basically, it can be used to store any kind of data. Okay, that we'll talk about in the few seconds. Now, class, when I was just discussing, I was keep on telling that node contains data and what? Address of the address of the next node. Correct, address of the next node. So here, forget about T for a moment, think like this one, this is a node class. and this is the data. What I mentioned, it can store only similar type of data. Means if you define integer, it will be integer. So T represents that part, data type. Okay. And this is your data part, right? The other part is the address, or you can say pointer. So address or pointer means what? If you think that what is your address represent, what it points to, it is a node only, right? It is a node only. So that is the reason I define node. Node of what? I define a variable next node. So basically your node contains data and address of the next node. Address of the next node meaning next node itself. Correct. So how will you represent node? Its a return type should be node, right? Guys, are you with me?
Yes.
Okay. Now, if you look at this data, right? Data, it could be integer, string, object, anything, right? And what is this next node? Pointer to the next node in the list. In the list, it will point to the next node. Okay. Now, so this is a basic definition of node class. This is a basic definition of node class. It contains two data members. This node contains two data members. One is the data part, one holds the data and other holds the or store the reference. This is a reference address of the next node. So far with me, guys? Okay, let's move on. Any doubt here? Okay, let's move on. I already mentioned, right? Let's talk about little about generics. Though it is not part of the linked list class, but I am just covering for the sake of your understanding, and you can revisit in more detail later on. Okay, I am just covering the basic part of it so that whenever you are implementing linked list, you should in a position to understand it very, very clearly. Okay. Now, Java generics. I already mentioned this is not in the scope of linked list topic. Okay. So what we have defined? Public class node T. Public T data. I am just focusing on this T part. Okay. And then this T part. So what does T represent here, guys? T stands for type. T stands for type. It is a placeholder for a real data type that will be provided when the class is used. What is T? T stands for type and it is a placeholder. What do you mean by placeholder? Means it is just some empty bucket and later on you will assign something into that bucket. Think like this one. Okay. T is a placeholder. Okay, your bucket, and you can assign the value later on. We'll talk about this one. T stands for type. It is a placeholder for real data type that will be provided when the class is used. Now, you can ask me question. Can we use another letter instead of T? Can we use? The answer is yes. We can, it is, we can use anything. Instead of T, you can use K, any letter you can use, any word you can use. Okay. T is just a convention, not a keyword. You know, in Java, there is a keyword, right? In the keyword you cannot use. Okay. So you can use any valid identifier. It's an identifier. What is T here? T is an identifier. You can use anything. But the meaning is same. It is a placeholder for real data type. Okay. So think like this one. Let's say if you are not be generic, if let's say if you are not generic, let's say if you are not generic, then later on if you need to store an integer data type, or if you need a switch to the string data type, you cannot do that one, right? So that is the reason we made it generic, so that at the real time it can be replaced with the real data type. Okay. Okay. Now node can store any type of data and it will be decided later. When you represent T, it means that node can store type of data, any type of data, and it will be decided later on. So public, for example, you can use E also here. Instead of T, you can use also here E. So then when you use E here, you can put E. What is the type of data? E. And node, then you can represent here, next node should be type of E. Any doubt here, guys?
No doubt.
Okay, let's move on. Okay, now I was mentioning, right? I was keep on telling that T is just a placeholder and it will be replaced later on. What do you mean by later on here? So this question answers that. How is T replaced at runtime? When you create an object, when you create an object, you replace T with a real type. This T is replaced with a real type. Let's for an example, take an example. Let's say if you create a node of type integer. What is T represents here? Integer. So integer node, now you created a new node. And what is the type of this data? Integer data type. Now into this node we wanted to store this data, right? Then we can store this integer data type. 20 is an integer, right? So here T is replaced with the integer data type. T is replaced with the integer data type. Chitej, Ritik, Kishan, are you with me?
Yes.
Okay. Now think like that one. If you, let's say if you wanted to use as a string, so you can define node here. T represents your string. This T here, T represents this string here. Okay, and then this string node in this the data you can assign is a hello, that is a string. So that means here T is replaced with string. So in generics at runtime, whenever you create the class, right, that class will be replaced with the real data type. That is why we called it that time placeholder. Okay, any doubt here?
No.
So see, I already mentioned this is out of linked list topic. Okay, I am just covering for you guys to understand, and later on you can go and revisit this one. Okay, let's move on. Okay. Um, okay. Now, why I mentioned that to implement this one, right? To implement this one. Hold on a second. Yeah. To implement this one, I mentioned node class and LinkedIn class. Okay. So let's understand this one. Now we will go revisit this linked list class, singly linked list. Okay. So we are talking about, I will discuss more about later on singly linked list and doubly linked list. But think like this one, this is just a linked list and we call it singly linked list. Okay. So whenever you define a singly list class, okay, again you define a generics here. Understand this part. Okay, so singly linked list is made up of nodes, right? What is linked list? Singly linked list or linked list? It is made up of nodes, and each node are connected with each other through a pointer. Correct? So singly linked list is made up of nodes that are linked together like a chain. I mentioned, right? One node, then second node, then third node, then fourth node, all are linked with each other. Okay. Now to access this chain, entire chain, we need a pointer. We need a pointer that keeps track of the first element of the list. So you have one first node, second node, third node, fourth node, right? At least you need the information about the first node, that is called head node. If you know about the head node, right, then you can traverse along the way till end. Why? Because because each node has the information about the next node. So far with me? So to access this chain, we need a pointer that keeps track of the first element of the list. We'll talk about it more in detail. If we know about the first element, as I mentioned, we can traverse the rest of the list without worrying about their storage location. Let's say, for an example, you have one node, another node, first node, second node, third node, fourth node, fifth node, sixth node, right? And if all are connected, and if you know the first node, that is head node, that means you can traverse along the way, because each node contains the address of the first node, second node, third node, next node. Basically, each node contains the address of their next node. That is the reason, since you have the address in the node, you can go along the way. Okay, so how will you define this how will you structure this singly linked list class? So first you define the node class. That is a node. This is the inner class. Class inside a class is called inner class. I will talk about later on, but for the sake, just understand that there is in this singly linked list class, you have defined a class node here. Okay, class node, and it has data and next node. It has data and next node. So correct. And what else it contains? This is the head node. There's a no head node. And what is the return type of head node? Node, because head node is the first element of the node. It represents the first element of the linked list. Obviously, there is a size. We will calculate. How will you calculate the size? And public, and there is a constructor. Why we constructor? Constructor, we need to create the list. So very first time, right? What will be the head node value? Null. Because very first time the linked list is empty. That means your head node points to null. Correct, na? Got it, guys?
Yes.
Okay. And in what will be the size of the list initially? Size will also be 0. So this is the whole representation of the single class. One thing you can observe here, interestingly, so here you have a generic type T, but here you don't have generic type. Okay, is it valid or not? Is it valid or not? Yes, it is valid. How? Let's understand that part. Okay, we'll understand that part later on, but I have just mentioned couple of notes here to understand this class. So here head node variable, you see this head node. Where is this head node? This head node variable. You see this head node variable, this head node. So head node variable of type node. What is the type of this head node variable? Node. So basically what it does, it points to the start of the list. That is head of the list, first element of the list. Always remember, head node points to the first node of the list. If head node is null, that means your linked list is empty. Got it? Your size will be 0. In the constructor, we have initialized the head node, okay, so that it becomes functional. It becomes functional. Think like this. Even though linked list doesn't exist, head node exists. Why? Because to make it functional, you need a head node, right? You need a head node, and initially it will be null. Why? Initially it will be null because your linked list is empty. Okay, if at least one node should exist, right, then only your head node will point to something. If the head node points to null, it means the list is empty. Okay, so that means your head node, you define a head node that represents the first node of the list, right? If the first node doesn't exist, that means it represents null value. Okay, now let's move on. Again, this is related to generics, not in the scope of linked list topic. I am covering this for the sake of understanding you guys, okay, and so that you can revisit it later. Since I am just discussing linked list and it came across, I am just discussing this part. Okay. Now in the class, why node T is not needed? I was asking this question, right? Here you have a singly linked list class and here T is a generic type, but here your node class doesn't have the T. Okay, here in the class, why node T is not needed means why reference or why T is not needed. Here node class, remember that here node class is a non-static inner class inside a generic outer class. Okay, let's understand this part first. You understand a static class, non-static class, right? If you don't understand, go and just understand what is a static class and non-static class. Okay, understand this part. It is very, very important for you guys to understand this one. Okay, I cannot cover all these topics in the link list, otherwise this will be lengthy. Okay, just go and read that one. I'm just highlighting or touching upon certain aspect to make you understand. Okay, now if you look at this one, singly linked list, this is a class and it starts from here, right? So this is the outer class. What we called it? Outer class. Okay, and this is what? Inner class. When you define a class inside a class, that class is called inner class, and the main class is called the outer class. Did you get the concept of inner class and outer class? Okay, and if you define a class with a static keyword, it will be a static class, and if you don't define with a static keyword, it will be a non-static class. Okay, just go and read that. Okay, now here node class is a non-static inner class because it doesn't have the static keyword. So here a node class is a non-static inner class inside a generic outer class. Why we called it generic outer class? Because this is your outer class and you made it generic by defining this angular bracket T here. And this class is doesn't contain the static keyword. That is the reason we called it non-static inner class. So, so your outer class is a generic type, but your inner class is a non-static and not generic type. And the question was in the class why node T is not needed, why generics is not needed for the inner class. This is the question we are trying to understand, right? So there is a rule in Java. Go and just read that. A non-static inner class, this class, a non-static, this is non-static, right? A non-static inner class automatically has access to the generic type parameters of its outer class. What it says, when you define a generic types for the outer class, and when you define any class with non-static class inside this class, meaning if you have an outer class and inner class is non-static, it automatically takes the reference of the outer class. So that is the reason we don't define this here. Guys, are you with me?
Yes.
Okay.
Yes.
So node always know, so your node class always know what T is. There's only one T owned by singly linked list. So you got right. The basic rule is a non-static inner class automatically has access to the generic type parameters of its outer class. So that means this class is already aware of and it has access to what is their outer class generic type. So far with me, guys? Okay, let's
Yes.
let's move on. Now, what will happen if you write node T? Here we understand that we don't need it, right? We don't need this one. We understand this one. But the question is, what happen if you write node T? Right? So you have two, then in that case what will happen is you have two different generics, one for the outer and one for the inner, and this is a bad design. This is a bad design. It creates confusion, poor readability and potential bugs. It can create bugs, though it is valid, but it is not recommended. Though it is valid, but it is not recommended. Okay, how the compiler actually sees your code, how the compiler actually in this case how your compiler behaves. Okay, so when you write singly linked list integer list is equal to new singly list, see the compiler interprets node as node becomes node integer internally. You just don't need to write it explicitly. Got it, guys? When you define a class, singly linked list, and when you define an integer type, so your internal implementation of the node class becomes node integer internally. Okay, so that is the reason you should not explicitly mention that. So far with me, guys?
Yes.
Okay, let's move. Okay, now the next question, I'm just covering couple of points. You can go and revisit and understand this part. When do we need T node? When do we need? We understand, right? We don't need to define the generic types for a static inner class, right? Even we understand that even if you define it can work, but it is a bad design and it can create potential bugs. Readability will be going for a toss and it create the confusion as well. Okay, but the next question is, when do we need this one? So node is a, when there are couple of use case. When your node is a separate top level class, meaning if it is not defined inside a class, means if it is not defined inside a class, and if it basically if it is not an inner class, then you can define like this, meaning when node is a separate top level class. When I mention top level class, meaning it should not be inside any class, then you can define this one. Here node must declare its own generic type. You must declare own generic type. Okay, the case 2 is node is a static inner class. If your node is a static inner class, meaning let's say if you define a class here node, and if it is a static, then you can define this one. This is, I mentioned, right, when you define a static keyword under the class, then it is called the static inner class. And it, so this static inner class cannot access outer class generics. When you define a static class, it cannot access the generics of the outer class. So that is the reason when you have a static inner class, you must declare the generic types. Okay, basically this is independent of singly linked list. Okay, so this is what I wanted going to cover today. Uh, Today we just touch upon the theoretical aspect of the node class. What is node class? Why do we need singly linked list? What are the structure of linked list? In the same line, in the flow, we also discuss couple of points about generics. We also discuss about couple of points about inner classes, right? Just this is the basic foundation. We discuss about head node, we discuss about tail node, all those things we have covered today. Okay, so we will slowly build up the foundation of the linked list. Okay, and then later on in the next class we are going to discuss what are the different basic operations we can perform. For example, if you wanted to insert a data into the linked list, now insert could be at a different position, maybe at the first element if you want to insert a new data, maybe into the middle, or maybe at the end. Similar case applied for delete. If you wanted to delete the first node or head node, if you wanted to delete a node between the list, or if you wanted to delete at the end, right? Or how will you traverse the linked list? So these are the concepts and problems we are going to solve in couple of classes. Okay, so this is just a basic foundation of the linked list. Go and please practice. How will you define a node class? How will you define a singly linked list class? Just go and write into your Eclipse or whatever it is. Who is raising hand? Okay, nobody, no worries. So go and just revise all these things. Okay, then in the next class, it will be more clear to you guys whenever we solve lot of problems. 15 to 20 questions we will solve, and that will be enough for the linked list. And before to that, that is the foundation I wanted to build it. Okay, so with that, we will wind up the class today. Thanks for joining again. Let me stop share. Thank you guys. Bye bye. Is there any questions from you guys? Okay. All right. Thank you. Bye.